Hi there. Thanks for joining us again. This is Space Nuts, where we talk astronomy and space science every week, twice a week, in fact. On today's episode, we're going to look at the progress of Artemis 2. There's an update for you, and it's good news. This is a weird story, an iron bar seen in space. And no, it is not a runaway spanner from the International Space Station, although that does happen. And something deadly that could be important in the origin of life. We'll find out about that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Back for more with stories galore is Professor Fred Watson, astronomer at large. Hello, Fred.
Good morning, Andrew, or good whatever part of the day it is when you're listening to this.
Yes, it's difficult dealing with a global audience, isn't it? Because you just don't know. You just don't know what time it is wherever. But
they vaguely know what time it is here.
Well, it's Eastern summertime is what it is, and we are approaching the hottest time of the year in this part of the world. And I've been looking at the forecast, Fred, because right now it's not too bad, low to mid 30s Celsius, which some people would be horrified by, but for us that's pretty normal. But next week we are expected to hit a string of 40 plus temperatures, peaking at 45. 45, which is, for those who don't use the metric system, that is 113 degrees Fahrenheit. So that's what's coming up for us. I mean, some people will hear this and it will already have happened and we won't be there next week and they'll wonder why. Well, that's the answer. We're just going to burn. We go burn. Yeah. Horrific. It's been horrific. We had a massive storm here the other day and it ripped through the city. I actually looked at it on the radar and it was only a really small cell, but gee, it was intense. It absolutely devastated the golf course. We lost a lot of trees and branches. But it happened all over town. So, yeah, we've had some pretty radical weather of late, and now we're going to hit a heat wave. And I think we've got like 6 or 7 days in a row at least over the old 100 Fahrenheit. So
there you go.
Looking forward to that.
Yes, I'm sure you are. It's a bit more temperate here on the coast, but we did have a week last Saturday, where it was 43 was the highest I saw. Yeah, I was out and about. And
it's been quite a few years since we had a 45 here, but I do remember one some years ago, and it was horrible. They actually forecast 47 or 48 that day, and it didn't get there, thankfully. But hopefully it won't do it again this year. But it's been a long time since we've had temperatures like this. For a few years in a row, we didn't even make 40. But we're getting at least 4 in a row next week. Anyway, and the other thing that's been really exciting this week is the auroral activity across the planet.
If you saw anything?
No, I went out last night and didn't see anything. It's too much light. And I thought, I'll go out of town. How far do I go? Where do I go to get a perch? Because it's pretty flat out here. But I didn't see anything. There was one photo I took where there was a little bit of a purple sheen in the distance, maybe. I don't know.
Maybe. Was that yesterday?
Last night. The night before was better.
It was. That's right. Yes.
This morning, of course, I wake up to all these amazing photos that people have taken, and they saw them as far north as southern Queensland. So
yeah, that's right.
It's been a very intense solar storm that's caused all this. But it looks like I missed the boat again, Fred.
Just got to come with us to the Arctic sometime.
Look, yeah. The other thing I saw this morning was there's a trip to the Arctic this year to watch the solar eclipse. That'll be a big one. I think that's in August. Is it? Or was that last year?
No. There is. I thought it was the Antarctic.
Oh, it might be.
Just kissed. Yeah, I think that's probably it.
Yeah.
There is an eclipse in August. It's the 12th of August. We'll be watching that from northern Spain. So we're taking one of Marnie's tour groups up there to see the eclipse.
Well, that's the one they were talking about.
Yeah, I think the one you're talking about was Antarctica, and it's not the same eclipse. Anyway,
all right,
never mind.
Yeah, I can see the one. The one I was thinking of is the one you're going to see in
oh, is
Spain.
that okay?
Yeah.
Oh, all right. Okay. So might start in the Arctic.
Yeah, it's crossing all the places we were visiting last year. So we're a year too early. Never mind.
Always ahead of the game.
Yes, always get out of dodge before the disaster. That's our philosophy. We've got a bit to get through, so we'll start with this exciting news, and that is an update on the Artemis 2 mission. Now, we only mentioned that a week or so ago, that it was one of the big things happening in 2026. It's starting to happen. They've started moving stuff.
That's right. So as we speak, the Artemis 2 stack, if that's what you call it, with the Space Launch System and its 2 solid rocket boosters and the service module, I nearly said Apollo there, the Orion capsule on top, is sitting on Launch Pad 39B, which is a very famous part of the launch facility at Cape Canaveral. So, it's made its journey from the vehicle assembly building to Launchpad 39B, which, if I remember rightly, is 6 kilometres, and it took 12 hours to do it. Yeah. So half a kilometre per hour. Is that right? Yes, that's right.
Yeah, I think it's like 0.82 of a mile per hour or something like that.
Yes, that's what I saw too. I think when you average it out, it comes to half a kilometre an hour, but I think it's a little bit more than that. In terms of, the maximum speed when it had accelerated up to full speed, 0.82 miles per hour. So that is the start of the journey to the moon, which is really quite nice. And Artemis 2, yes, the mission will, we hope, actually launch within the next few months. What we do know is that there is to be a wet, what's called a wet test, is that the right word? A wet dress rehearsal, that's the correct term, where it's fully fueled up and basically undergoes a countdown, a dummy countdown, everything as if you were about to launch, but you don't launch. And we're told that it is not going to happen any later than basically next week our time, or the week after next, which is February the 2nd is the date that we've got. So that will be exciting to see how that goes, whether everything goes flawlessly or whether they find a gotcha and have to wheel it back to the vehicle assembly building, which has happened
That's
before.
happened before, hasn't it? Yeah.
It did with Artemis 1. In fact, I think it happened 2 or 3 times, didn't it, if I remember rightly? Because they've got to get this right, and they've got to, it's got to be right, and it will be. Is the bottom line. Yeah. Yes,
indeed. But it's exciting. I think it has been delayed. It was supposed to go last year, wasn't it?
That's correct. Yes, indeed, that's true. It's. The whole project has suffered delays. There is one bit of good news, though, which has come out of Congress. I think I should get my terms right, but the NASA funding for next year, or for this year, seems to be much more secure than was previously thought. Some of the big cuts that were being planned have sort of evaporated, and I think the funding level for NASA this year is not that much. I think it's on a par with what they received last year. Notwithstanding the fact that, yes, the Mars sample return mission has still been axed from that budget, but that leaves room for some other things to be funded. And no doubt there'll be further talks on how we get these canisters of Martian soil back from Mars before we all die.
Yes. Yeah, well, let's hope somebody riding a trail bike up there one day comes across it and goes, "Oi, what's this? What's this? Who left this here?" But it's good news. And we should mention the astronauts involved: Reed Wiseman, Victor Glover, Christina Koch, and they're all from NASA Americans. And then you've got from the Canadian Space Agency, Jeremy Hansen, and they'll be journeying out and around and back over a period of 10 days, which is about the same length as the average Apollo mission. Although there was one mission that only went 5 days because, well, they couldn't stop because they...
Yeah, that's right.
They had a bit of an accident.
That was another story.
Yeah,
but it's true. It's reminiscent of Apollo 8.
My Christmas Day, wasn't it?
Christmas Eve, I think. I can't remember.
Something like
Christmas Eve. I think it was Christmas Eve. Yeah. 1968. But what's different though is I think their orbits around the backside of the moon will be at a higher distance from the lunar surface than we saw with the Apollo mission. So these astronauts will hold a record as being the furthest the furthest that humans have been from planet Earth. After the end of their mission. So
that record currently held by Michael Collins.
That is correct, yes.
Yes.
I think
In fact, there's a famous photo I think I've mentioned before that Michael Collins took, which showed the moon where Neil Armstrong and Buzz Aldrin were on the surface at the time and Earth in the background. And it basically said every human being that's ever existed is in this photo except one. I think that's great.
That was him. Yeah.
I mean, you think
what a way to feel lonely.
It's pretty, it's pretty deep when you take a photo and someone says to you later, do you realize you're the only human being in history that's not in that photograph? I reckon that's incredible. Yeah. Of course, people will come back and say, oh, but what about the people on the other side of the planet that weren't in the picture? Well, they were on the planet, so they were in the picture.
Yeah. We know.
We can use a bit of creative license, surely.
Yes, that's right. That's right.
We should also mention why this mission is happening, and it's based around putting long-term humans or a long-term human presence on the lunar surface. But the ultimate goal is to create that springboard for missions to Mars. So it's part of a long-term venture, I suppose.
Yeah, I think actually, it's got an immediacy about it that makes the Mars issue perhaps not reducing its significance, but giving us a good reason to be on the moon anyway, and that's the possible resources that are on the moon.
Yeah.
Plus, there's still a geopolitical aspect of this, exactly as there was in the 1960s. The Americans are very keen to get there before Chinese taikonauts walk on the lunar surface, which they're certainly planning to do by 2030. That is what we hear. Yeah. But you're right. Artemis 2 is a precursor to Artemis 3, which is likely to be not next year, but the following year. There's still a lot of work to do on that, where 4 astronauts will land on the lunar surface. And that, in a sense, is perhaps the opening gambit for a permanent or a semi-permanent human presence on Mars. And yes, you're right. Eventually, that will lead to, we hope, expertise that we can gather that will take astronauts to Mars, not to colonize it, but to explore it in a suitably ethical way.
You hope not to colonize it.
Yeah, well, that's right.
Okay. Very exciting news, and hopefully all will go well with the tests. In fact, they're talking about doing it more than once if they've got time. It'll be it'll bring about the same level of excitement, I suppose, that we enjoyed in the 60s with the Apollo missions, because you've got a whole new generation that weren't around to see that, and so this is all fresh and new for them. I reckon
that's right.
That will revive the interest in space science as well, I suppose. If you'd like to read all about it, you can log on to SciTech Daily, but I think you'll probably find there's plenty of news on plenty of platforms, including the NASA website. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a break from the show so I can tell you about our sponsor, NordVPN. With NordVPN, you can explore the web securely and privately no matter where you are, whether you're streaming space documentaries, downloading data from the International Space Station, legally of course, or just browsing from a coffee shop, NordVPN has your back. Fast connection speeds, no data logs, and protection across all your devices, including your smart TV, plus access to content from around the globe. It's like having a wormhole to the internet. Sorry about that. Without the black holes. Haha. Right now, Space Nuts listeners get an exclusive deal. nordvpn.com/spacenuts. Huge savings, plus an extra 4 months free. That is fabulous. nordvpn.com/spacenuts helps you stay protected online and gives you everyday access without any fear that your private data will be stolen. That's nordvpn.com/spacenuts. And don't forget to use the code word spacenuts at the checkout. nordvpn.com/spacenuts.
3, 2, 1.
Space nuts.
Okay, Fred, this weird story has been published in a paper about a nebula that is demonstrating something that at this point in time is inexplicable. They know what it is. Right. They don't know why it is.
Yeah, exactly. And so this story is about perhaps one of the most famous celestial objects in the northern sky, an object called the Ring Nebula. Because it's shaped like a ring. It's in the constellation of Lyra, one that certainly I've been aware of ever since I first became interested in astronomy in the 1950s. It is a planetary nebula, and that is a bit of a misnomer term. It was one coined by William Herschel in the early 1800s, because these things kind of look like planets, but they're nothing to do with planets. They're not in the solar system. They're clouds of gas, and we now know that they are the bubbles of gas that are puffed off by giant stars in their old age. And we also know that the sun will go through a phase where eventually it's surrounded by a nebula, a planetary nebula, very like the Ring Nebula. So we know a lot about that nebula, and there's a sort of slightly personal aspect to this story, because a telescope that I worked on quite commonly in the 1990s, the William Herschel telescope, which was then operated by the UK. I think it's now the UK and some other... sorry, I'm going to cancel this. I can't take that call. Don't know whether you heard that, but my phone is ringing. It's ringing in my earphones. Sorry.
Oh, okay.
Yeah, sorry. It's all right. I'll call them back shortly. It's the telescope that was built in the late 1980s, commissioned I think around about 1990. As I said, I worked on it in the 1990s. A 4.2 meter telescope, which is situated at a place called El Roque de los Muchachos, which is the name of a peak in the island of La Palma. It's a volcanic peak, and there is a major global observatory there. It's as I said, 4.2 meter telescope. I think it's now jointly operated by a number of different nations. It was built by the Brits and was for a while something like the third biggest telescope in the Northern Hemisphere, I think. It has an instrument on it, which is sort of...
Let me guess.
Descendant.
It's a saxophone. Sorry, couldn't help.
It's an E-flat trombone. It's an instrument which is, I was going to say, is a descendant of let me rephrase that. It is an optical instrument, which is a descendant of something I was very deeply involved with when I was there. I was project scientist for a thing called a spectrograph, which is the device that splits up light and lets us see that barcode of information in the light of a star or galaxy or indeed a planetary nebula. But the new version of that, we were using optical fibers to look at individual objects. The new version uses optical fibers again, but in such a way that you can look at an object like this nebula, and for every point on the image, you can get a spectrum. And it's a technology which is known as integral field spectroscopy. And they have built something called a LIFU, which is a large integral field unit for the WEAVE instrument, which is the WHT Enhanced Area Velocity Explorer. Great stuff. And the bottom line is, to get to the end of this long rambling story, this is a brand new instrument that is just being tested. And what better object to test it on than this lovely Northern Hemisphere nebula, the Ring Nebula. And so that's what they've done. A group of scientists, mostly I think from the UK, they've used the Ring Nebula just to make sure that the WEAVE spectrograph works properly and does everything they want it to. And they've uncovered a complete surprise that has blown everybody's mind because nobody understands it. And that is exactly as you've said, it's an iron bar. Now, when you talk about a bar in astronomy, it's not something you prop yourself up against to get over all your problems, although you can do that if you want. Usually it's a structure, a linear structure. Often made of stars. Galaxies often have a bar across the middle. We call them barred spiral galaxies. And that bar is made of stars which are circulating in a very elliptical orbit around the center of the galaxy. So it looks like essentially a solid bar of material. It's actually made of stars. So the bar in the Ring Nebula is not made of stars. It's made of gas. Yeah. But what is interesting is that gas is highly ionized. That means energized a version of iron. So this is a plasma of iron atoms. And one of the interesting comments that comes out of the data that's been released on this piece of research is that the total mass of the iron that's in that bar is comparable to the mass of Mars. That is quite significant. And I love this comment. Its length is about equal to 500 times the orbit of Pluto around the sun. And so it's, if you imagine Pluto's orbit, multiply it by 500 times and then take its diameter, that's how big this iron bar is. So it's not an iron bar in the sense that something you can pick up and hit somebody on the head with if you're that way inclined, and I'm certainly not. But it's an iron bar in the sense of a barred structure in what is completely normally expected to be quite spherically symmetrical, because this is a bubble of material. The Ring Nebula is a bubble of gas, and yet here in the middle of it is this linear feature, a bar made of highly ionized iron atoms. So as you said at the beginning, Andrew, the big question now is, where did it come from?
Yeah, why is it there? What happened to create that? Because it sounds like it's unique. There's nothing else like it yet found.
Not that we know of, that's right. But nobody's looked for iron in the center of these objects. So I think there is, the sort of, as the article, and we might quote, because this is from our old friend Universe Today, it's by Evan Goff. The bottom line is that there are two. Let me just read, because this is quite nicely put. There are two broad explanations for this iron bar. One is that it reveals something new about how the central star, and that's the star that it eventually gave rise to the nebula, how the central star ejected its material. The other is that the iron bar is the remnant of a planet that was vaporized and destroyed by the star as it expanded into a red giant. That's a really, really interesting conjecture, that what we're seeing is perhaps the remnant, the vaporized core of a planet, perhaps a rocky planet that was in orbit around the star when it turned into a red giant. It was vaporized, and what we are left with is this streak of highly ionized gas, highly energized gas made of iron across the middle of the nebula. Really, really interesting results there.
Yeah, absolutely. And the pictures that they've gathered are spectacular. It looks amazing.
Yeah, it does. It's quite extraordinary. There's a quote from Janet Drew, who I won't say I know, but I certainly have met her a few times back in the day. She's one of the study's co-authors at University College London, says we, this is in a press release, we definitely need to know more, particularly whether any other chemical elements coexist with the newly detected iron, as this would probably tell us the right class of model to pursue. In other words, whether it was ejected from the star or a vaporized planet. Right now, we're missing this important information. So, yep, really, really interesting stuff.
Yeah, and now that they've found it, they know what to look for, and they may well find that this has happened quite a few times, that you might even have one in your closet. You never know.
What is interesting to me, and it's a tenuous link here, but perhaps the most famous planetary nebula in the southern hemisphere, and it's one that is very familiar. It's called the Helix Nebula. Beautiful, again, a ring-like structure. We just yesterday, I think, or the day before, received some new images of that from the James Webb Space Telescope, which are absolutely staggering. They show structure on the sort of inner edge of this bubble of gas, which is what the Helix Nebula is as well, which is it's unfathomable almost. What we're seeing is little bubbles of gas being stretched out into these myriad of fingers. It almost looks like a grassy paddock. It is quite extraordinary. It's well worth a look if you can find it, Andrew. And I encourage our listeners and viewers to look for the James Webb Telescope image of the Helix Nebula just released. Yeah,
we'll keep an eye on that. But if you want to read about this particular iron bar discovery, you can read it on what is the universetoday.com website, or you can go to the paper, which was published in the Royal Astronomical Society monthly notices of. We could say it the other way around and you'd be right. But the pictures are spectacular in themselves, but the mystery itself is quite extraordinary. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Our final yarn, Fred, takes us into a bit of a mystery land. Something deadly that could be important in the origin of life. And, if you would ask people, what is deadly to human life and life in general, you would come up with a few well-known things, including hydrogen cyanide. And that is the topic of the discussion.
Yeah, that's right. Now, I preface this discussion with something that you and all our listeners know already, and that is that I'm no chemist and certainly no biochemist. But this is it's a really interesting study that I think comes from Swedish scientists, and it's about hydrogen cyanide as a molecule. HCN, its chemical formula, which we know occurs commonly in space. It's one of these molecules that seems to be readily formed in the coldness of space. So we find it, for example, in comets. And that's one of the reasons why, there was panic in 1910 when it was known that there was hydrogen cyanide in the tail of Comet Halley, and the Earth was going to pass through the tail. And so I think all these quack chemists made up their potions to stop you being poisoned by hydrogen cyanide. The fact that it's, very, very rarefied gas wasn't something that impinged on their consciousness. They just made money out of it. Yeah. Anyway, it's in comets. It's in clouds of interstellar gas and dust. It's also present in large amounts, actually, as an ice in the atmosphere of Titan, Saturn's moon Titan. And it's not only on the atmosphere, but it condenses out deposits onto the surface as well. And so don't
lick the rocks, kids.
Don't lick the rocks. Yeah,
don't lick the rocks.
In fact, don't breathe the atmosphere, which you wouldn't want to anyway, because it's pretty horrible. But so that has led scientists to look more closely at the chemistry and sort of physics as well of hydrogen cyanide, and in particular, what they've found is that it has essentially electrostatic properties that may encourage it to assist with the formation of other molecules. It's apparently got really strong electric fields at the ends of a solid crystal of hydrogen cyanide. And what they're saying is that might be a property that would allow this deadly chemical, nevertheless, to assist in the building up of prebiotic molecules, the organic molecules that we think are basically the building blocks of life. It's really a really interesting piece of work that these authors have highlighted, that maybe this thing that to us is anathema, hydrogen cyanide, maybe it's the reason why we're here, because of reactions that might have taken place. And of course, that has some interesting implications for Titan. If it's commonplace on Titan, Titan's a world that we think could harbour life, maybe in its under ice oceans. It's an ice world like many of the other satellites of the outer planets, but also has these seas and lakes of liquid ethane and methane. Maybe there are reactions going on in there that involve hydrogen cyanide that might have created organisms that use these liquefied natural gases, which is what they are, as their working fluid. Who knows?
Well, and that's something we've talked about before, because when we think of life, we look at ourselves, carbon-based life forms that breathe oxygen and have a heavy reliance on water. But why does it just have to be that? Why can't life develop in an environment that we would find toxic and, basically hostile? But if you can create the catalyst for life on a world like Titan, why couldn't it develop independently as a totally different life form?
Something quite different, that's right. And, that raises the question, how do you recognise that it's actually life if it's so different from our living organisms?
Well,
we don't really have a proper definition of what life is.
No. And some people argue that a virus isn't a life form.
Yeah.
So is a virus life? I've seen that argument tossed around a few times. So what debate rages?
Yeah, a definition that I think NASA uses from time to time is a living organism is a self-sustaining, self-replicating organism capable of Darwinian evolution. And I actually think a virus would satisfy that.
I think it would. And it does it fast.
Yeah, and it does. And I think I've got one at the moment, which is why I feel so crook these days.
Yeah, they hang on, don't they?
They do.
Well, that's the natural order, isn't it? The fight for continuity. That's what a virus does. Yeah. All right. Very interesting story. And don't go to the chemist asking for hydrogen cyanide because you want to, revive your cat or something. It doesn't work.
Because it's got interesting electrical properties. It would be a good excuse, wouldn't it? Oh, yes. Well, we'll sell you some if that's the case. Yes.
Yeah. Why not? Yeah. I don't think you could get it very easily, could you?
I don't know. I don't want any, but I don't know how you'd get it.
You'd have to go to an illegal arms dealer or something, I think. But yes. Yeah. Anyway, if you want to read about that, it's in the universetoday.com website. And I think there's probably a paper that I have overlooked where it's been published. But or you could go to the acs.org website. ACS Central Science is where you'll find the article. We're just about done, Fred. Thank you very much.
Oh, you're welcome, Andrew, and thank you for having me. As always, it's a pleasure.
It is good fun. We really enjoy ourselves, and hopefully the audience does too. They've been sticking with us for a good many years now, which we greatly appreciate. And between shows, don't forget to visit us on social media, Facebook, Instagram. We might pop up in other places that I'm unaware of. I don't know. We'll have to go and lean on an iron bar and have a few drinks and figure it out. And on our website, you can also look around at the shop or the Astronomy Daily news feed if you want to sign up for that. There's plenty to do on the website, so check it out. And thanks to Hugh in the studio, who couldn't be with us today. We were talking about the weather earlier, Fred, and I don't know if you know this, but Hugh's from New Zealand, so once the temperature hits 6 degrees, it's way too hot for him to go outside. So that's why he can't be with us today. And from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.